optics sa du to ri to lokela apoi mo zo chu kan cover to thawa ma se na kena kan le le po level po optics mi chu anwa solve tai la so unit 7 ania tung le ku thara cha image zong ron channel le mi wa unit 7 to to nia dual needs of radiation matter ania radiation kan ti khan light kan soi na tho ni te kha khla tu re ni matter kan ti jot khla sakhat soi na nia chumi um je dual to 2 dinare that means light has characteristics of radiation, that is wave, and matter characteristic. Matter has mass, so light has energy related to its mass and energy related to its wave characteristic. Kha kan zir tur hu chu ni dual chu 2 tina kha chu kan perfect ton thonga chuan le khubi karon man pol le mai thea chan chu lai ji thak dan zir lo chu vak lo tam ta kan ziak ve tho wangin chuan heta kan zir tur ho chu photon kan ziranga chuan emission kan ziranga photoelectric kan ziranga Einstein's equation of photoelectric effect kan ziranga chuan dual nature kan zir bok nga hei hi mak nga puchna bota chapter ide lekania mak nga kha a score a full mark a mu the ni te kha kan kha cha hi har sa lem lo or sam tak mark scoring du tu mai nia chu wangin lai chu in lo en u lo ka duwa tian thiet lo zia ka nga hei hi internal metal plate ni ta se metal plate we have many electrons or protons, but we will consider only electron parts, so we have many charged particles. These are suppose electrons. Electron katina san kan thiat them jok na electron lo poni ve thonia tian electron tam tak nei ta ne so on these electrons can move backward and forward directions according to the energy or potential we supplied to this plate, metal plate. So when the light waves, or let me say its ray, strikes the electron, light ray has energy equal to h nu. H to energy, h Planck's constant. Planck's constant. It has a value equal to 6.62 into 10 to the power minus 34 joule per second. Ani into electron volt dinani ev dikhi electron volt second ya kana meta joule ka electron volt chan ter na ya so hey light energy kan nei chu ni so in light frequency antinita frequency to c by lambda ni lambda to wavelength c to speed flight hey wavelength of light light as a wave we use its wavelength, so when the light falls on a particle or metal plate, then with energy of this much, then the electron starts moving, suppose in this direction. So the motion of electron, that is charged particles, produce electric current in opposite direction. And it's on if I can move electrons, that means I can get current, electric current. So the best example is solar plate module can debate the solar plate here. Hey nisa and pota so on current electron kalta current rom kalta ni they can current can connect yan battery hey battery ti kan meta battery kan no charge the mai chin ta ni battery kan charge an no kan no mang mai chin ta. That is how the solar plate works. It based on this effect, and the motion or ejection, or emission. That means if one electron is suppose move to another place, then we call it as ejected or emitted. Oh, so me ejection, emission thế chứ, không bị effect ha, photoelectric effect, thì chứ này, photo means light in a photo. Oh, so photoelectric kan thì so light và current electric kan lâu này kan mấy tờ kan bị effect thế ha, photoelectric effect kan thì the phenomenon of emission of electron hết anh gì cái electron from a surface of metal is called photoelectric effect. Here, when light of sufficiently low frequency or sufficiently high or sufficiently low wavelength around it, so we let link it on sufficiently high frequency. High frequency. High frequency means if this nu is high increases, energy also increases. That means energy of this light is increases. So we need high frequency to move or eject the electron from its position. So to akal dan turun ta masa yang vanga electron ka light around tlak ma move lo ngian di kan ti chuan entai la electron is a matter. Electron is a matter kan ti chuan thil engemaw nei ve tho khani ta ne is a matter waves kan ti ta matter ani chuan entila engwa khuma ka mut zana kan mut thin kan ti chuan zana khuma kan mut hian energy kan waste tlem ber thu chungin an mu hil chin te tu ka chin rol vekang a chan chu thut nan ka energy ka mo wanga ni mut nan chuan khai ba low energy ka mo niam ka nei to lo the lowest energy that I need is when I fall asleep. So wangin we need minimum energy so we sleep. Likewise, electron has a minimum electron needs minimum energy in order to not waste any energy unnecessary. So it is in still position, at rest position. So when it is at rest, it has least energy. Chu vào chân rest ông ta đi. So me rest ông chu nó đã son cái tum ta đi. When I fall asleep, if someone tries to sieve the place where I slept, so that man will have to do some work on me to move from one to another place. So likewise, when electron in this position want to if we want to move this to this position, so we have to apply some energy. That energy is from light waves. So that light waves must have high energy. When I sleep, the man who tries to sieve my place will have strong enough to move me from one to another place. Min chơi thấy được, min chơi càng được chân à chắc tao ngay, min chơi càng thấy lưu chuan, min son thấy lâu, thì na nè, so cái tiền thấu khoa nè, so cái case to talk tai la, so and then we'll consider another case. Here we have many electrons. These electrons binds together each other. They binds together each other with another charged particle. Suppose this is positive. Negative, positive always attract each other. Attractive force, it's not a repulsive. So if this is attractive, so to separate between this positive and negative, I have to do This the energy which binds electron and proton is called binding energy. That binding energy in metal, it is not binding energy. We call it as work function. Work function. Work function. And yeah. To me, binding energy item to move one electron from one place to another, I have to supply energy more than that binding energy so that I can separate or break through the binding energy. To me, work function to me. Work function to electron who anh bind về tất xia metal là khăn anh bẹt về tất đó cái metal anh bẹt về tất na bộ chen nó tụ energy có một zat cả binding energy cho nên cho nên electron like eject thì tụ khan minimum energy to eject electron khá cầm một ta này anh minimum energy kan ti chuan minimum energy must be just greater or equal to the binding energy of charged particles khane to me minimum energy kan nei na tura minimum energy depends on frequency only. Your H Planck's constant is a constant, does not change, so I can vary only the frequency of light. So the minimum frequency required to eject electron from a metal surface is called threshold frequency. Threshold frequency, minimum frequency, and it's a threshold frequency. And here is maximum velocity, maximum wavelength. In opposite, maximum wavelength required to eject electron, threshold wavelength. Not well zero. So frequency zone minimum frequency required to eject electron from metal surface is called threshold frequency. And in terms of wavelength, it is maximum wavelength. Dekha, hele taila. A time career. Kaka particle nature. Like an poimo can mozwal ho chuloni ta a. So in tahian entire me wavelength, photon wavelength, wavelength of electron, photon, and the photon can take on. Here light is considered as matter as well as waves. If you consider light as a wave, it is called radiation. Now, if we consider light as a matter, that is, light as a mass related energy. So, if light has a mass related energy, I can use equal to mc squared. M is mass, c is speed of light. So I can use this one. If I use this one, I consider light as a mass particle, but actually light has not a mass because light never rests, it always moves. So rest mass of light is 0. That particle constitutes which makes the light particles are called photons. Then photons kan ditong photon ito with photons. Photons are energy of light, a packet of energy. Nito photons kan ti kani. So nature of photons are one. Photon has 0 rest mass because it never rests. It always moves. It also always in motion. So photon has any rest mass. It has 0 rest mass. It moves with photon moves with speed of light because photon itself is light. Moves with the speed of light. So I have here, this is energy of radiation equal to h nu. So nu is c by lambda. So I can have this one, h equal to c by lambda. So from Einstein's equation, this is Einstein equation. Hey, Einstein equation. So Einstein equation equal to mc square. E, here's E, so these are equal, so I can write mc square. Thì khan kan lu ni theta. Ani chuan c le c ka cancel anga. I have only this one thing. mc equal to h by lambda. They have lu ni ta. mc mass into velocity. Mass into velocity tinania. Mass is into velocity is momentum ani. Momentum. Ariato mass into velocity ka momentum ani. And it's momentum to mass into velocity and hatani. So and it's momentum of photon is this. Kanti chuan photon chuan mass alone reng ti a entiang hata. So mi wang chuan eta dual nature kanon tina chan khani. Chuan in hemi photon hi okati momentum of photon to his constant and is here. If I eliminate this constant, I can write it as P is if H is eliminated here, so equal to sign we also eliminate it, so I can write it as lambda. So momentum of photon is proportional to 1 by lambda, or inversely proportional to 1 by lambda. Dikha controdonia. Chuan can be derivation b khi lai to equal ne noi le tuka lekabul hui mi te kha kalau entir zoi chunga chu nakina a derivation in lo manga ga lekabul hui mi te han a fel fai deu rim thima dikha oh lai mi te hi ania the here do the screenshot henga aron chwada ka kanita ai nang renga setlem a fel fai deu lekin ka hria so in that the lie here lie as we can lie here so you better do kan nei to electron volt hini electron volt. What is electron volt nakina ron te mate and this one is energy gained by electron when it is accelerated through a potential difference of 1 volt. That means here I have a metal plate and I want to move this electron from this terminal to this terminal. And to move this electron, I'll supply external volt. External volt. So when I supply external volt of 1 volt, and I'll measure the acceleration of or energy of electron, then it will come out to be this much of energy. If I supplied 1 volt, the electron will gain energy of this much. That is 1 electron volt. So 1 electron volt equal to 1.6 into 10 to the power minus 6. Minus 6 anya. So in like kilovolt, 1 kilovolt, kilo electron volt anya. Kilo means into 10 to the minus plus 3 meter into 10 to the power 3. And it's 1. This 3 and this 3 will add and give minus 16. So 1 kilo electron volt equal to this much into 10 to the power minus 16 joule, and 1 MeV mega. Mega means million. Million means 10 to the power 6. 6 plus 19 is minus 13. So I have 1 MeV equal to 1.6 into 10 to the minus 13 joule. 1 MeV depends on the nuclear physics of chuan kha lo le ta se hei no tan lo siam anga hei no ta lo siam to chuan hemi derivation takhi no ta ka pek bel to lo chim ka hria ka lo ka siam pon ka hlo wa a chan har a siam har lo ema ta fe fa sia ka siam sak ni ta ka rom ta ka lo ta lo ta ka ni point nang mani pon kha cha siam har lo kurang ai ta ila chuan what is photon ti kha point mo ya lo chin che je lam chumo lo chin che tur chu what is electron volt chuan mi expression ho hi angai boka chuan what is photon and what are the characteristics of photon ati chuan Misi ka to ka. The rest mass photon is zero. Ito ka. A photon travel with the speed of light. Ito. A photon has energy. Kaya can derive ka photon tani ka. Maybe point huntal hi. No hiya mula. What is photon? Characteristic of photons. Ito nga. At least point huntal kayo ito nga. Kakaluzia kula. Tika rin. Kan dito ko rin nga. Kan zir nem ang ren china so heta photoelectric emission ti pona kena ron zir thale nga tunai ron zir le tur chu what is threshold frequency zeka soi ba kha threshold frequency threshold wavelength work function so photoelectric effect kami definition ho ka lo zir phot ola ti chuan no tan lo siam thap dong nia so electron volt ka sei to ho le photon ho ni khani logic thlapula chon hetla derivation ho te kha hi a choi mark thum te chuak le me thinta ho te si yen right em question what is photon te ron te ga me ron zong kha mark thum me mark thum a jong ko vela toi berang mi vai thiam nge nei to te khan kan du to kang